All right, you guys, let's continue our discussion on equations of lines with a couple of application problems. So let's read this one. So it says, Anita calls a plumber because she's having problems with her kitchen sink. The plumber charges her a flat fee of $25 plus $12.50 per hour. And we have two questions to answer. A says, write a linear equation where y is the amount of money charged based on the amount of time x. And B says, how much will Anita pay the plumber if it takes him 3 hours to fix the problem? Okay, so the first thing that we have to do, because this is a word problem, let's try to identify the important information. So what we know about this plumber is that they charge a flat fee of $25 plus $12.50 per hour. Okay, so if you don't know what a flat fee is the money you get charged regardless. So if the plumber comes to her house and he doesn't fix anything, she still has to pay him $25 regardless. Okay, and then she will also have to pay him $12.50 for every hour that the plumber stays. Okay, so for part A, if they want us to write a linear equation where y is the amount of money charged based on the amount of time x, we first need to identify those two variables that they want us to use. So the problem says that y equals the amount of money charged and x equals the amount of time. So we have those two variables we're going to use. And the problem told us that the plumber is going to charge a $25 flat fee, and he's also going to charge $12.50 per hour. Okay, so any type of linear equation that we have, remember it's going to take the form, if we're in slope-intercept form, y equals mx plus b. Okay, so in the context of this application problem, m, remember that's how your line is changing or how your function is changing. So if we ask ourselves in the context of this problem, what is changing? Well, the $12.50 is what's changing because it changes depending on how much time is spent. Okay, so we're going to put $12.50 where m is. And then b is your y-intercept. So it's that constant of the function. It's the value of the function when x equals 0. So that would be the same thing as our flat fee. So we would add it back here to the back of our function. Okay, so we have y equals 1250x plus 25. That's going to be the function that we're going to use for part A. Okay. Now, part B says, well, how much is the plumber going to charge Anita if he spends 3 hours on the problem? Well, we've already identified our two variables are y and x, and y stands for the amount of money charged, and x stands for time. So when they give us 3 hours, 3 hours is a time. So that means we're going to let x equal 3, and we're going to plug 3 into the function that we created in part A. So we would have y equals 1250 times 3 plus 25. And when we add those values together, we get 6250. So if that plumber comes and spends 3 hours at Anita's house, she's going to have to pay him $62.50. Okay, cool. Let's look at the second problem. All right, in this second example, the directions say, it has been shown that having a student leader in the classroom helps students succeed. At Valencia College in 2006, 42 sections or classes had supplemental learning leaders. In 2008, 226 sections had supplemental learning leaders. This shows that the program has experienced a tremendous growth. Use the given data to find an equation of the line that predicts the future growth of the program. Okay, so I know this is one of those problems where there's a lot of words and it seems like there's a lot going on. The first thing you always want to ask yourself, well, what did the problem ask us to find? Well, our task was given to us in the last part. It said use the given data to find an equation of the line, okay, that predicts the future growth of the program. So we've been doing this throughout this whole section. If they want us to find the equation of the line, remember in order to do that, you need two things. You need to know the slope, and you need to know at least a point. Okay, now as we look at this problem, we haven't explicitly been given the slope or points per se. So what we do know, okay, let's go back and highlight that. We do know that in 2006, there were 42 sections or classes that had supplemental learning leaders. And in 2008, there were 226 sections, okay? So even though that doesn't look like a coordinate, our data is paired together. Each one of those pairings is a year and the number of sections that had supplemental learning leaders, okay? So it's kind of like it's a point. So if I come over here, okay, and we realize that we can pair the data, okay, we can say that for a year, we can give the number of supplemental learning leaders. So in 2006, we know that there are 42 sections that have supplemental learning leaders, and in 2008, we know that we have 226 sections, okay? Now, since those are 2 points now, we can find the slope by using the slope formula. Y equals m equals y squared, y2 minus y1 over x2 minus x1, okay? Now, when we do that, I'm going to go ahead and plug in those values that I had. So remember, it doesn't matter which point you designate as point 1 or point 2, you get the same answer. But for me, I let the 2006 be my point 1 and the 2008 be my point 2. And I plugged in those values into the slope formula, and I ended up with 92. Okay. Now that I have the slope, I can go ahead and plug that information into point slope form. Remember, all you need is a slope and you need a point. So I use the 92 and 0.1 and plug that information in here. Okay. And then, since I wanted my equation in slope-intercept form, I cleaned the equation up. So I distributed the 92 to everything that was in the parentheses. And then I added 42 to both sides of my equation. Okay. And when I did that, I get y equals 92x minus 184,510,000. Okay. Now, it said that it wanted an equation that showed growth. Okay. A reason that I know that my answer is correct is because my slope is positive. Okay. Because the slope is positive, this means that if I were to graph it, the line would be increasing from left to right. That would show an increase or a growth. So I know because my slope is positive, this displays growth, so I must be on the right track. So the equation that would show that, what my author asked me, is this. Okay, cool. I hope this makes sense.